This video will accompany the notes for Chapter 4, Sections 1 and 2. In Chapter 4, we're going to look at ways to gather data. One of our primary goals in this course is to learn how to use the information in a sample to learn about a population. Don't forget, as we move through the material, that the population is the group you'd really like to learn about. If we have population data, we can examine it directly. The purpose of selecting a sample is to learn about the whole population when the whole population is unobtainable. At this point, it may be worthwhile to revisit the definition of population and sample in Chapter 1. Recall that statistical inference is the process of using the information contained in sample data to draw conclusions about what is happening in the population. If we are going to use the information contained in a sample to learn about the population, we need to discuss how to select a sample and how to collect the data. In Section 4.1, we're going to talk about experimental and observational studies. Recall the following definitions. Again, it may be worthwhile to revisit Chapter 1. In Chapter 3, we learned about the explanatory variable and the response variable. We will begin by discussing two types of studies commonly employed to collect data. When a researcher collects data by actively controlling the explanatory variable or variables, we call this study an experiment. A researcher conducts an experimental study or experiment by assigning subjects to certain experimental conditions, then observing the outcomes on the response variable or variables. The experimental conditions, which correspond to the assigned values of the explanatory variable, are called treatments. So, for example, we may have a population of people that we split into two groups. We would assign one of the groups to eat nothing but fast food, and the other group to eat no fast food at all. So in this case, the two different experimental conditions, or the treatments, would be to only eat fast food or to eat no fast food. When a researcher collects data by simply observing and does not influence the variables in any way, we call this an observational study. In an observational study, the researcher observes values of the response variable and explanatory variables for the sample subjects, without anything being done to the subjects, such as imposing a treatment. So for an observational study, we would take the same population of people, but this time we would simply observe, are they already eating fast food or are they already not eating fast food? We wouldn't tell them what to eat. Read the following studies and determine if they describe an observational study or an experiment. Pause the video, and when you come back, we'll look at the solutions. The first one is an observational study. This is because she recorded whether the students entered as groups or individuals, but didn't tell anyone to go as an individual or a group. The second one is an experiment. This is because the veterinarian is telling the dog owners which food to use. For more practice, there's a link in your notes from Khan Academy. In an observational study, lurking variables can often affect results. A lurking variable is a variable not observed in the study that influences the association between the response and the explanatory variables, due to its own association with each. Recall the ice cream example and shark attack example from Chapter 3. In that example, the lurking variable was weather. Read each of the following and see if you can identify a possible lurking variable that is not accounted for. Pause the video, and when you come back, we'll look at some potential lurking variables. For Part A, a potential lurking variable is world population. This is because as the world's population gets larger, there's more people eating salmon and more people eating asparagus. For the second one, a possible lurking variable as well. The more wealthy a person is, the more likely they are to own a private movie theater, and the more wealthy a person is, the more likely they are to buy a sports car. The third one is gender. Males tend to have shorter hair, and males tend to have shorter hair and tend to be taller. Establishing cause and effect is central to research, but it is not possible to establish cause and effect definitively with observational studies. We may see an association, but association does not imply causation. In an experiment, the researcher has control over whether the treatment and the subject receives. Therefore, if an association is found between the explanatory and response variables, it is more plausible that a causal relationship has been discovered. So it's important to remember that observational studies can almost never be used to establish causation. As a consumer of information, you should pay close attention to this important fact. There are times you will be presented with news articles or information on social media which claim that two variables have a causal relationship, but the data may have been collected from an observational study. You want to be able to identify these claims and critique them. So for example, you may see things like this. A surprising secret to a long life is stay in school. This headline suggests that if you stay in school, you'll live a longer life, but if you were to read this article further, you would find out that this was from an observational study, and so this could just be an association without causation. Since experiments are preferable to observational studies, why don't we always just conduct experiments? Reasons include that an experiment may not be ethical, it's difficult to practice to ensure subjects adhere to the instructions of an experiment, and some studies may not be interested in causality. Give an example where an observational study would be useful to help scientists understand the risk of a particular agent's or exposure. Give a reason why an experiment would not be appropriate. One example here would be whether or not we would like to see if smoking causes damage to the lungs. In order to perform an experiment, we would have to tell some people to smoke and tell some people not to smoke. This would be unethical. So for this reason, we would need to use an observational study. Sometimes we rely on data already available to answer a question rather than conducting a study. Informal observations such as this are called anecdotal evidence. For example, you may remember some grandparent who ate fried food 3 times a day and lived to be 100 years old. You may claim that a low-fat diet has no effect on longevity. There's no way to tell if these are representative of what happens in the population, so this is not reliable evidence. Take a moment and read the example on the top of page 4 of your notes. Pause the video, and when you come back, we'll look at the answers together. For part A, you need to identify the response and the explanatory variables. Notice in the example, half the subjects were randomly assigned to a low-carb diet, in other words, given a low-fat diet. So here the explanatory variable is type of diets. Subjects on a low-carb diet lost more weight after 1 year compared to those on the low-fat diet, so our response variable here is weight loss. Was the study an observational or an experiment? Since the response variable was randomly assigned, then we know that this was an experiment. Based on the study, is it appropriate to recommend that everyone who wished to lose weight should prefer the low-carb diet over the low-fat diet? Why or why not? Notice here we're trying to make a claim about everyone who wished to lose weight, when the study only looked at those without heart disease or diabetes. So it would not be appropriate to recommend this to everyone, since those in the study were only those without heart disease or diabetes. A sample survey selects sample of subjects from a population and collects data from them. In the field of statistics, a survey does not just indicate an opinion poll or questionnaire, it includes any information gathered from or about the subject. A sample survey is a type of observational study. The subjects provide data on the variables measured, and there is no assignment of subjects to different treatments. A census attempts to count the number of people in a population and to measure certain characteristics about them. It is different from a sample survey, which selects only a small part of the entire population. Although it is the intention of the census to sample everyone in the population, in practice it is not possible. Can you think of a reason why not? In section 4.2, we're going to look at good and poor ways to sample. The sampling frame is the list of subjects in the population from which a sample is taken. Ideally, this would be the entire population. However, this is not always possible. For example, if I have a question I want to ask all students at EKU, possible sampling frames might be the student directory or a list of registered students from the registrar's office. The sampling design is the method used to select the subjects from the sampling frame, and a simple random sample of n subjects from the population is one in which all possible samples of that size have the same chance of being selected. Often it is just called a random sample. Important, notice that the definition of random sample says nothing about the responses that people give. A simple random sample is solely defined by how people or other elements of interest are selected to be in the sample. In the field of statistics, random samples are very important. We need random samples to be able to make conclusions about the population from sample data. In later chapters, we'll talk more about sampling variability, sampling distributions, and why random samples are important. Your turn. Use the definition of simple random sample to indicate whether the following statements are true or false and tell why. For each situation, ask yourself, does everyone of interest have the same chance of being selected to be in the sample? The first part is completed for you. Pause the video, and when you come back, we'll look at the answers. Part B is a random sample. Notice here, they obtain a list of all student IDs and use a random number generator, which gives every group of IDs the same chance of being selected. Part C. Part C is false. This is not a random sample. They want to sample people who live in Kentucky, but only those in the hometown have a chance of being selected. D. D is also false. This is not a simple random sample. They are interested in how EKU students feel, but only the ones living in the dorm have a chance to be in the sample. Next, we're going to look at the example on the top of page 6. The dog has had an accident on the floor. It's so messy that 2 members of your household are needed to clean it up. To keep things fair, everyone agrees to choose the 2 lucky winners at random. A number is assigned to each member of the household as follows. So first, we're going to start out by looking at all of the possible samples of 2 people comprised from the 5 people in the household. Okay, so here are our 5 people. And notice here there are 10 different ways that we could select a group of 2 distinct people from the 5. So part B asks, what is the chance that a particular sample of size 2 will be drawn? Well, notice, since there are 10 different groups of 2 people, there is a 1 in 10 chance that any particular sample of size 2 will be drawn. What is your chance of being selected? Looking at our 10 different groups, notice that you are included in 4 of those 10. Therefore, you have a 4 in 10 chance. Now the question is, does Beth have the same chance as you of being selected? Notice there are 4 different groups that involve Beth, so yes, Beth also has a 4 out of 10 chance. So how can we select a simple random sample? The goal is to select our sample from a population randomly. Previously, we saw that a simple random sample of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be in the sample selected. In practice, people often use random number generators generated by a computer or calculator to choose samples. If you don't have technology handy, you can use a random number table, and the website listed in the notes gives an example of the random number table. So let's look at how to select a simple random sample. First, you'll label each member in the population a numerical label of the same length. So as an example, suppose that we have a class of 20 students and would like to take a simple random sample of 5 students. We start by giving each student a label consisting of the numbers 1 through 20. Below are each of the 20 students and their labels. So notice that's what we have here. To take a random sample of 5, we can visit the website given in your notes. We will need to generate one set of 5 integers where the integers are between 1 and 20. So in your notes, we have some sample output, and here it is here. So notice we requested one set with 5 unique random integers taken from the 1 to 20 range. So looking at our set here, we're going to select students corresponding with IDs 8, 10, 11, 16, and 20. Are there other types of random samples? In this course, we're going to focus on simple random samples, but there are many other types of random samples. For all random samples, the goal is to obtain a sample that accurately represents the population of interest. Watch the video in your notes from the Pew Research Center located on page 8. Methods of collecting data in sample surveys. Once we select the sample, it's important to consider how to collect the data from the sample when distributing the survey. Notice in your notes on the bottom of page 8, we have 3 different methods with potential advantages and disadvantages. Sources of potential bias in sample surveys. When a random sample is ideal, it often isn't feasible. Notice that to take a random sample, we need to list every member of the population. A list of the entire population may not be available. Another potential problem is that it may be impossible or too difficult to contact all members of the population. Sometimes the conclusions cannot be made about the population in interest. Instead, the conclusions can only be made about a more feasible group from which you can select a sample. As a result, generalizations of the conclusions are limited to the population from which the sample was obtained. Definition: sampling bias. Sampling bias occurs when non-random sample does not adequately reflect the characteristics of the population and results in poor inference. Results in having a sampling frame that lacks representation from part of its population. Non-random samples can have many different issues. A good website which summarizes the different types of samples can be found at the link located in the middle of page 9 of your notes. A variety of problems can cause responses from a sample to favor some parts of the population over others, and then results in what is known as bias. So we're going to look at some examples. Suppose you want to estimate the average number of hours that students at EKU spend studying each week. We're going to critique each method of sampling given on page 9 of the notes. The first one says to go to the Math and Statistics Tutoring Center in the Wallace Building and ask all the students there how many hours they spend each week studying. In this scenario, the sampling is based on a related variable. In other words, studying is related to being at the tutoring center. This is an issue because students at the Math and Statistics Tutoring Center will probably already be studying. You could tweet asking all EKU students how many hours they study each week and use all the responses you get. In this scenario, we are relying on the information from volunteers. This is known as a volunteer study. Samples comprised of volunteers are biased. Volunteers tend to be people who feel strongly one way or another about a topic. Usually people without strong feelings do not volunteer. We could stand outside Case Dining Hall and ask everyone going in how many hours they study each week. In this scenario, we have a convenience sample. Convenience samples contain bias because they often miss parts of the population. What other types of errors may occur when we take a sample? Does taking a random sample take care of all bias? No. Even with a random sample, we still run the risk of having a biased sample. Other things that could cause bias include the following. People selected in the sample choose not to participate, question wording, inaccurate responses, undercoverage, and there are many other possibilities. So we always need to examine the specifics of each study. In practice, think hard about the potential sources of sampling bias and try your best to avoid them. Recall that sampling error occurs when the statistic is not equal to the parameter due to looking at a sample instead of a population. This type of error is expected, and we have statistical methods for estimating sampling error. The more problematic type of error is non-sampling error. Non-sampling error is an umbrella term for any other type of error besides sampling error. These types of errors are not limited to when we look at samples, but also apply to when we look at a whole population. The website in the middle of page 10 of your notes describes some types of non-sampling error. Definition: non-response bias. Non-response bias occurs when we can't question people who are eligible to take the survey. This usually occurs when people are asked to take the survey but refuse. They may refuse to take the survey for different reasons. Even those who do not respond may not respond to all of the questions, resulting in missing data. Questions that make people uncomfortable or more likely to cause non-response error. Things like drug use, sexual habits, finances, and etc. Definition: response bias. Response bias may occur within the actual responses being made. For example, the interviewer may ask leading questions that could result in subjects responding a certain way, or subjects may lie for any number of reasons, such as they may think their response is socially unacceptable, or they may give an answer thinking that this response is what the interviewer prefers. Definition: coverage bias. Coverage bias occurs from not allowing all members of the population to have an equal chance to be in the survey. Notice, by definition, a simple random sample cannot have coverage error. As we move forward in the course, keep in mind that our goal is to learn ways to use the information in a sample to learn about a population of interest. We need to be cautious when we do this, as not all samples will provide proper statistical inference. We need a sample that is randomly selected and one that has accounted for potential of non-sampling error. Take a moment and read this scenario and see if you can identify sources of sampling bias, non-response bias, and response bias. When we come back, we'll look at the answers together. Recall that sampling bias occurs when a non-random sample does not adequately reflect the characteristics of the population and results in poor inference. So in this case, notice that we had an internet survey of 1,001 teenagers. This is obviously not a random sample, so we may have sampling bias. Non-response bias might occur because there may be some students or kids that don't feel comfortable answering these questions and refuse to answer. And we may also have response bias because the answers they give may not be honest. Next, we're going to look at some poor ways to sample. The following methods may be necessary, but are in no way ideal. In a convenience sample, the subjects are selected due to convenience, availability, or proximity. So it is easy for the interviewer to obtain the data easily and cheaply. For example, say I want to know all EKU students' opinion on the political issue, and I stand at the corner of the Wallace building next to the street and ask people their opinions as they walk by me. How would this introduce bias? So notice here, if we're interested in all EKU students, there are many students that have no chance to be in this sample. So for example, students that only take online classes are very unlikely to walk by the Wallace building and be included in this sample. In a volunteer sample, subjects self-choose to be in the sample. There's no way to know if the sample reflects the population. For example, suppose the Today Show wants to know the opinion of all Americans about the new hairstyle of a celebrity. They post a survey on their website and ask the viewers to respond. How would this introduce bias? Recall that volunteers are generally only people that have strong opinions. So in this case, you're only likely to get those members of the population who feel very strongly one way or another. Also, people who don't watch the Today Show have no chance to be in the sample. One last thing to remember is that a large sample does not guarantee an unbiased sample. Many people think that as long as the sample size is large, it does not matter how the sample is selected. This is not true. If the sample is not representative of the population, a larger sample size is not going to produce any better results than a small one. This concludes the first part of the video for the Chapter 4 notes.